Here, there's tutor. I'll be here at lunch up until your quiz, so today and tomorrow. But then, if you don't have second lunch, you can go first lunch to G2 and after school to G2. And you can just take in like any of the stuff that you got and just say, hey, this is what's going to be on our quiz, and they can work with you on whichever piece you need. All right, so we are recording. My smart board is not working great, but it should be able to get us through. All right, so this is a list of what you're going to want to have for the quiz. So the main thing I would say, yellow sheet, pink sheet, white sheet, these first three things. Yellow sheet is graphing from Y-intercept or slope-intercept form, which is Y equals MX plus B. Got that? No. Actually, bell just right, good. I looked with the bell hat. That was the warning bell. Yeah. Yeah, that first bell is the warning bell. You didn't know that? That thing's been going off for like 3 weeks now. Do you realize it's already the 4th week of the quarter? I would. I didn't realize it was. I thought it was the 3rd week. This is the 4th week already. So these are the things. Again, yellow sheet is when you need to graph. I mean, it kind of says this on those, but so it's when you need to graph from an equation in that. There's a white sheet that says steps to graphing from standard form. So you got a bunch of white sheets, I know, but that white sheet says steps to graphing from standard form at the top. Pink sheet is the one we use to solve for equations. So that's solving equations, if you don't remember it. Like solving for a variable, I mean. The gold sheet says you how to tell which kind of an equation to create from a word problem. That's what the gold sheet is about. This is gold here, not yellow. So that's gold. Yellow is the lighter yellow. And then the other ones are just any practice worksheets you got. So phones can go up, like I'm not even going to deal with it. If I see it one more time, it's going to go in your backpack. So you need to put it in your backpack now, or the first time I see you look at it, you'll put it in your backpack. Right, Damani? Damani, come on. All right, I mean, again, this review is for you. Like, I'm not standing up here wasting my time. I'm doing this for you. So pay attention, please. A lot of you are going to be struggling tomorrow, and if you aren't paying attention today, I'm not going to feel well sorry tomorrow. I'm sorry, in 2 days. Next class. Everybody got there? I see a lot of people without stuff out. Again, I see a lot of people without stuff out. There we go. All right, that's what I'm talking about. I need to see what you don't have is why I'm doing this also. Because I'm going to make some extra copies that stay in this room that you don't have to walk out with. And if I only make 5 and I got 10 people that don't have something, then 5 of you aren't going to have it. So get your stuff out so I can see how many people are missing stuff. That's a pretty good start. Do you have the white sheet that says steps to graphing from standard form? It's got an example worked out with a graph at the bottom of it. Oh, actually, this is not a bad one, too. If you have this, I didn't write this up there. Boy, I'm glad I saw that. This will help you if you struggle a little bit to pull out the slope and the y-intercept. We did almost every possible example you could have. It tells you how to do one. I don't think it's going to be hard on the quiz. This one's also not a bad one to have. I didn't put it up there because I don't think you'll need it, but I mean, it's not going to hurt to have it. The main white sheet, though, is this one that says steps to graphing from standard form. That one right there. So here, can I hold that up? This is the one that I said white sheet right here. It has the graph at the bottom. I already did the example for you. So I took the equation, I went through the steps, and then I graphed the line for you. So there's nothing you had to do on this one. It's all done for you. We're going to do a couple practice ones today, though, like those. All right. So I think you kind of know what to get. If you're still getting it, that's fine. So that's all the stuff on there. We're not going to go over what we did yesterday. So for those that raise your hand, you were not here yesterday.
And I got a yellow.
You do have it or you don't have it?
I everything before.
There you go.
I got a sheet.
You were not here yesterday, so I'm not going over what we did yesterday. It was the only day we did it. We talked very briefly about it one day, but so you need to watch yesterday's lesson because that is a pretty good sized section of the quiz, Mark. And I made it worth quite a few points because I thought it was really easy. Now we didn't all think that in some of the classes, so I'm a little worried about it now. But I mean, I still think it's easy. Like if you go back and watch that, you're just plugging in, for this one, you're just plugging in numbers and does the left side equal the right side? If it does, then yes, it's on the line. If it doesn't, it's not on the line. For X and Y intercepts, basically you could just put the point on the graph and is it an X intercept? Is it a Y intercept? Or neither. So I'm hoping that we put a little time in if we weren't getting that yesterday. So we'll go over everything but those two today. First, most important section, graphing. Let's get rid of that. All right, so, my smartboard is all messed up. We don't need that for now. It's gonna be annoying. There. All right, so first question you have to ask yourself is which sheet do I use? If I give you an equation, how do you know? Am I using the white sheet? Am I using the yellow sheet? Because those are the two sheets about creating a line from an equation.
White.
But how do you know? So look, you can look at Willow's next to you. She's showing me the yellow one. How do I know? Do I use the yellow one or do I use the white one that Damani just pulled out? Same one I just showed you a second ago.
Then you use the yellow one.
How do I know? No, my question is not like how do I know? What do you look at? Because I'm not going to give you, I'm not going to say on the quiz slope intercept form. I'm not going to say standard form. I'm just going to give you an equation. You've got to know which one to use. How do you know? What are you looking for if you just see an equation? Gregory. Yeah, I'm going to say it a different way, but yeah, I think you're good. What would you say?
If the line is by itself.
That's what I would say. If you get an equation, so there's two equations. You're doing the same thing to figure it out. Doesn't matter what the equation is. You're looking for where the y variable is. So you find the y variable. And you say to yourself, is that y variable all by itself on one side of the equation? Nothing else with it, just y. There it is. There it is. If it's all by itself, then you use this, well, yellow sheet, but it's slope intercept form. So again, y all by itself, yellow sheet. So you need to make that note somewhere if you're not clear on which one to use, because I will not tell you tomorrow. Said that for 2 weeks. I will not tell you which way to graph it. If it's not all by itself, that's when you use the white sheet and you have to plug in 0, solve for y, plug in 0 for y, solve for x, and that'll give you the 2 points you need. You could actually plug in 0 for this too, and then solve for y, and plug in 0 for y and solve for x. Might not work as well, but might, probably will actually. Well, x might not work. So anyway, that's what you do, is y all by itself. That's the only question you need. For the what? You might not have been here for that because that was only a 1-day lesson. Everybody should have the yellow sheet, the white sheet with a 1-day lesson.
You said yellow sheet and white sheet.
All I have is the white sheet to give out. I'm not giving out the yellow sheet. I will have copies in class for people that don't have it, but I've given out too many copies of that over and over again. People lost them by now. And you've been here. I'll have a copy for you, the quiz, but again, you haven't missed days like he's missed days. All right, so let's do one. I'm going to do one that has kind of everything you need in it. And then if we have time, we'll do another one. We'll do that. All right. What's the first question we said you have to ask yourself?
Is the y by itself?
Is the y by itself?
Yeah.
Then we need to do y equals mx plus b, slope intercept form, or yellow sheet. If y is all by itself. So yellow sheet. On the yellow sheet, it gives you the steps. It says in the lower left-hand corner, do this, 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 and this. If you haven't really used that, today's your last chance, because again, I'm not going to tell you how to use those steps on Thursday. We've been doing this for a whole 2 weeks. That's gold. So
Same thing.
are they is that the same color as that sheet? Those two are the same color. No.
I'm not colorblind. That's gold and yellow. But this
Right,
is more
so then
like
you're using
dark
yellow.
orange, yellow.
So then you're using the yellow one.
Still the same shade. So this one, right, though?
Yes, yellow.
All right. Why do I have this?
Because that's for word problem. We're going to do that one too. We'll get to that one.
Okay, so you did that one.
It said gold on the first slide.
What is this?
So it says on that yellow sheet is the very, again, lower left-hand corner under the rectangular black or gray box. It says put a point, and then in parentheses, you might still have this. I want you to scratch through it if you still have this. So it says something like that in parentheses. Just scratch all that out that's in parentheses. Get rid of it. So it should now, if you scratch that out, just say, put a point on the y-intercept. So I would start by doing this. I won't take points off if you don't do this. But let's say you get some other stuff wrong, but you get this right, I might give you some points just so you don't get a 0 on that problem. Write down whatever the slope and the y-intercept are, just out of the equation, just pull them out. So what's the slope from that equation? Yeah, the slope is in front of, well, no.
Isn't that the line?
No x. X is not part of the slope. I do mark off if I ask you what is the slope and you say x, like negative 3x in this case. X is never part of the slope. What was that again, Ryan?
You can't do that.
I can't do that or you can't do that?
Like, you can't put the X.
Yes, you don't. X is, this is negative 3 times x. They're not the same thing. They're two different things. Negative 3 is the slope. X is a variable.
Bro, I didn't do that.
We did all of this. It's review. So, if negative 3 is the slope, what's the y-intercept? Which is a b. B stands for y-intercept. That's been up for 2 weeks. Some of you noticed it, some of you didn't. It was up for the last exit ticket. A lot of you definitely didn't notice it was up last exit ticket because you missed a lot of the questions on that topic. So what's the y-intercept? 1. It's not a bad idea to write positive 1 so you kind of remember where to put it on the y-axis, especially if it's a negative number. So, like if that would have been subtract 1, I would have written negative 1. I now just put a point on that positive 1 on the y-axis. Some of you are still making the mistake in putting it on the x-axis. It is called the y-intercept. Again, it says y-intercept up there. You should never forget it. You should have also written it in your notes, but I haven't taken that down in 2 weeks. It'll be up Thursday. If you forget which axis it goes on, look up there. It says y. That means it goes on this axis. That is the y-axis. So it goes on the up and down axis. So there's 1 point. I wouldn't give you half credit for just putting 1 point on the graph, but I give you quite a bit of credit. Now, though, we need to figure out where's my other point. I need a second point to draw a line. So step 2 says what? So we just did step 1. And again, when I say steps, this is this actual steps part is just this little corner down here. Yeah, it says the slope number needs to be a fraction. We need a rise and a run number. Well, we don't have a rise and a run number right now. We just got negative 3. So I need to make that into a fraction. And I just do that by putting it over 1. It says all of that in step 2. Put it over the number 1. So I did that. Now here's where people are messing up, typically. You're not doing this step, those of you that are messing up. Write down the formula. Do not just write it down somewhere on your paper, in the problem that you're graphing, write rise over run.
But why?
Hmm?
Why do we do that?
Because people mess up when they don't do this. Next to that, it says, take your fraction you created, or if you already had a fraction, take that and write it right next to that rise and run. Now it makes it a lot harder to mess up your run and your rise number, like to flip them and go the wrong distance for the run and the wrong distance for the rise. I see it every single quiz, and I'll see it again. No doubt somebody's going to mess it up. They're going to, instead of going right 1, they're going to go right 3 or left 3 or something that's the wrong number. Guaranteed. Happens. I mean, if it doesn't, I might faint. I might have a heart attack and you won't see me the next week.
We got a reward?
So, for giving me a heart attack?
No.
Really? You think I'm going to give you a reward for giving me a heart attack? Yeah. Tell you what, we'll have a pizza party. If nobody, now, again, this has got to be through all my classes, not just this class. Because there may only be like 15 people in here, so the odds go down. It's only 15 people when you take the test.
Shoot the pizza.
I tell you what, I'll do something for this individual class if nobody does it. If nobody gets this part, now that includes direction and everything. You go the wrong direction, like let's say you do go left and right, but you go right instead of left or left instead of right. If nobody messes this part up, and again, there's no math involved in this. If you'll remember, we did this also. A positive run means count right. You should already have this, but if you want to just write it real quick, if it's not on your yellow sheet, negative run means count left. You should really never have a negative run the way I've gone over it. Positive rise means count up. Negative rise means count down. I'm going to get rid of that in a second, but if you want to put that real quick on your yellow sheet, I'll leave it up for a second. Man. Why did that not work? Oh, it did work. There, I can kind of keep that on the screen while we finish the other one, probably if I zoom out. All right, so now using my rise and my run number, I start, and it says this on your sheet, but I'm just kind of going over it. I start at the Y-intercept that I already put on the graph, and I just count using my run and my rise number. Well, if it's a positive run, it says count right. So I'm going to count right 1. It then says if it is a negative rise from here, I don't count from here again. I count down 3. So again, count the hops. I hop once right, I hop 3 times down. That is where I put my second point. You could continue that pattern if you wanted to. Go right 1, down 3, right 1, down 3. You could reverse it. So I could reverse both directions. Go left 1, up 3, left 1, up 3. The points should all be in a line. I'm only really going to grade your first, assuming you very clearly mark your first 2 points. I'm just going to grade those first 2 points. If you don't very clearly mark them and you just draw a line, I'm going to make sure every single point matches up. And if it doesn't, then it's wrong. Because that's what a lot of people do. They just don't really know what they're doing, so they just try to draw a line through somewhere. So that's it. That's graphing slope-intercept form. Put a point on the y-intercept, right? This is a fraction. If it's already a fraction, then you just use the fraction. Right next to rise over run, write that fraction, and then count. You'll always count to the right, because I say always make the rise number negative. If you have a negative fraction, let's do that real quick. Here, you can do this one on, there should be a blank graph on this yellow sheet. Well, some of you have 2 blank graphs. The bottom one should definitely be blank. Let's do this one on your yellow sheet. So you have another example. So y equals negative 1/3 x plus 2. I'll do this one pretty fast, so if you have questions, stop me. And again, I went over this in 6th grade yesterday. Nobody ever asks a question when I do something, and yet half the class doesn't get stuff. I know that because I see the quizzes later. If I'm going through something, I don't care if you just yell stop. Like if you don't want to raise your hand, I'm not looking. I mean, I know some of you aren't willing to do that, but tell me to stop if I get to a point and you don't know what I'm doing. If you're not willing to raise your hand and ask later. Because if you don't get it, I need to know that you're not getting it. And trust me, you're not the only one. There's a bunch of people that aren't getting it, but they're not willing to do that. They don't want to like say something in front of all their peers. Some of you are okay with that, so I need you guys to speak out. All right, so that's my first step. Again, following the yellow sheet, it says put a point on the y-intercept. Well, I just did that. Second step says if I got rid of all the count, positive run, positive rise, all that stuff. Oh well. Hopefully you got it written down. So now it says if you don't have a fraction, make it a fraction. Well, we already have a fraction, so we don't do step 2 in this one. Step 3, it says write rise over run. Don't skip this. Write rise over run. Next to that, write the fraction right next to it. If you have a negative sign, so again, the negative will normally be right in front of the fraction. Put it on the top number. Because that's where it's normally going to be if you already have a negative, just like it's not a fraction, it's just a negative number in there. It'll be on the top number anyway, so just always make the top number the negative. Don't make one negative into 2. Don't make both numbers negative. You can't do that. That's the only thing you really have to be careful with. Oh my goodness. Jeez. All right, so now I just follow my steps. A positive run means I go right 3. A negative rise means I go down 1. And that's where my second point goes. And again, you could keep doing that, right 3, down 1, right 3, down 1 if you wanted. I'm not worried about that. That's a horrible line, but I'm just going to grade the first 2 points. So you should now have that graphed on your bottom graph. It should have gone through these points there. It's got, oh, I did hit that. Actually, I hit those 2 points. Okay, just that last point. All right, so now you should have another example that you can use on that yellow sheet, the bottom graph. Next, we have to know how to graph in standard form. This is the white sheet that says steps to graphing in standard form. So again, this one I showed a second ago. So standard form, I'm going to create something that's a little, looks really complex. It's really not. So we'll say 5x subtract 6y. Man, that's not going to work. Let's do it differently. Equals shoot. Don't like that either. I'm trying not to make sure I don't repeat the same question on the quiz. I don't remember what it was. Oh wait, I'm sorry. This won't. Never mind. This won't repeat. What am I thinking? There. let's say, oh, negative 20. So I'm going to do this one then. Oh, if you want, I don't know if you were in here, if I said it. If you want to do like another page, because we don't really have. Wow. So we don't really have, I mean, you do have a sheet where we graph this, but there's not an extra spot on the white sheet. So if you raise your hand if you want one of these to do like an example, another example.
Me.
Have one. You got one of those? I'm just gonna hand it out there. You already have that one. Have that one. Okay, John, wake up. John,
Slap
wake up.
back of the head.
Here, pass these. Take one and pass it back. You guys got to do. Yeah. Take one and pass it back, please. Get some more out. If you don't need it, then just pass it back. So again, this is just the label standard form graphing example, something like that.
Oh, I have one.
Well, but again, I don't want, is it blank?
Yeah.
Okay, if it's totally blank, that's fine. I don't want you to use a graph you already have that maybe you put other types of graph on.
I grabbed one
Oh, okay. You can just put them behind, have Greg put them behind him or something, that's fine. All right, so standard form. So write that equation over one of the graphs. That is oh, how do we know which sheet to use? White or yellow sheet? What's the question we ask?
There's a Y by itself.
Is Y by itself? Is Y by itself? No, absolutely. Y is not by itself, not even close. So we need to use the white sheet that says graphing in standard form. So this one's a little more complex. Well, I think it is. I don't know. Maybe not. Depends on the person, I guess. This is where I'm basically doing what we did the other day, where we just plugged in a number for X and figured out what Y would have to be. We did that yesterday. We said, well, what if Y was 6, X would be, or sorry, if X was 6, Y would be 4, because it was X subtract Y equals 2. Remember yesterday? If Y was 5, I'm sorry, if X was 5, Y would be 3. Again, it just had to be X subtract Y equals 2. So we just created a whole bunch of numbers because it was an easy equation. We're doing the same thing here. We're just going to say, well, if X was this number, what would Y have to be so that we could make the left side equal the right side? We're just going to start with 0 for X instead of picking some other number, because 0 makes our math really easy. That's going to allow us to put a point on the x-axis and a point on the y-axis. Those are going to be x and y intercepts. So I'm going to just say, all right, well, let me plug in 0 for x. What if, I'm basically saying, what if x was 0? Well, if x was 0, I'm going to solve out and figure out what y would have to be. This just goes to 0, so I don't need that anymore. Remember, a negative sign is glued to the number that follows it, so I need to bring that down with the 10. Now, to solve that, what do I do? Solve for y. How do I solve for y? I always think this is easy, but sometimes it's harder because we don't see it as often. How do I solve that? It's the last step of a two-step equation. We would divide. This is negative 10 times y. Why I need to do the opposite? The opposite of multiplication is division. Remember, when I'm solving, I'm always doing the opposite. So if I divide by negative 10, then I got to divide by negative 10 over there. And I get y is positive. Negative divided by negative is positive. So be careful. I will have to take points off on that. I'm a little more strict, well, a lot more strict really on the math. So if y is 2, I put a point on the y-axis on 2. For some reason, some people were putting this point on the x-axis and the other point on the y-axis. I don't know why. They were plugging in a number for x, 0 for x, so they, for some reason, thought that meant they were solving for x. Well, no, we're not solving for x. We're saying x is 0. So technically, this coordinate would be 0, 2. Because we said x is 0, and then we got y is 2. So that point, if we graph the line, would be on the line. That's how we're creating the line. So now we do that same exact process. We're just going to, instead of plugging in 0 for x, we're going to plug in 0 for y. Other than that, it's the same exact thing. I'm going to start with the original equation. Like, I'm not even going to take any variables out yet. Now I'm going to say, okay, well, I'm going to plug in 0 for y this time. So 5x doesn't change. Times 0. Negative 20. Well, 5x subtract 0, which is what that becomes. That's just going to be 5x. So I don't really need this. This whole thing just kind of goes away. So I get 5x equals negative 20. Again, that is 5 times x. I need to do the opposite, which is divide. And you have an example also on the white sheet already worked out for you and graphed. So negative 20 divided by positive 5 is negative 4. So x is negative 4. Again, if I solve out and I get what x equals, I need to put that on the x-axis. So right there. Here's my second point. And then you just connect them with a line. Oh, kind of missed it. I'm really not going to be able to probably write. There's just that one line. Any questions on? Oh boy, that's definitely not going to work. Oh, that's pretty good. Any questions on how we did that? We're going to do one more real quick, just so you have two examples really. You can try to do it. I'll give you a minute to try to do it on your own to practice, and then I'll do it so you can check your work. Is anybody still writing that? I'm going to erase that and just redo it there. You better not be checking your phone.
I was about to take a picture of it for that. If I was going to put on YouTube.
Well, I did see a picture of a whiteboard.
Oh,
So smart. White. Smart. Like when I saw the cover of her phone, she had a picture of that. I can tell when there's a bunch of little pop-up boxes on a black screen versus a picture of a white or a smart. How am I going to change this around to give you another example? Oh, I know what I'm going to do. I know what I'm going to do. There's only so many ways you can do it.
The most part is easy. We haven't got very far into it yet. This is easy, but we haven't really got far into the other ones.
I don't think this is a real tough quiz. I mean, I say that before every quiz, though, and then it winds up nobody does very well. Well, not nobody, but seems like there's some people that do well and some people that really don't do well. There's not a ton of people in the middle. A few, but
They don't ask for help.
it's not a normal. Well, it's kind of you either know how to do it or you don't. Almost.
So you think I do well?
Yeah, you typically do pretty well on quizzes. I think. I don't remember all your quiz grades off the top of my head, but I feel like you do pretty well. There was one exit ticket where I think you didn't understand it. That was about all I remember. I don't even remember which one that was. I can remember being a little surprised that you didn't get it.
Alright, this is good.
And it still wasn't horrible. Just normally you get on the exit tickets. Normally you get A's and B's, and then I think on the quiz you probably got a B or a C.
Maybe a high.
Ready? All right. So here you go. Here's the next one. Which way am I going to do it? X subtract 4y equals, I hate that I just did that. Dadgummit.
You do a problem.
Well, there's a reason why I don't want to do it a certain way, because I'll explain it in a second, but a lot of times kids are just taking the two numbers in here. So this would be what in front of the x? There's no number.
1.
So a lot of times kids are just taking the numbers that are in the equation on this side, and they're just putting them on the x and the y axis. And sometimes that actually works. But it won't work on the quiz. I'm telling you that right now. Do not just take the numbers that are in front of the variables and plot them on the graph, because it will not work. You've got to go through that process of plugging in 0 and solving for the other variable. So if I plug in 0 for x, 0 subtract 3y, negative 6. Well, 0 just kind of goes away, so negative 3y equals negative 6. Divide by negative 3, divide by negative 3. So I get y equals positive 2. Oh, I get a point. Y equals positive 2. You guys try to do the second part. I meant to give you some time to try to do that one. So I did the first part. Now what would you do from there? Because it seems like for some reason the second time is when people mess up. You did the first one. I've had kids do the same exact thing again, plug in 0 for x again. I've had kids try to use the 2 that they solved and got, somehow use that to figure out the next point. And then I've had some kids just stop it. So I want you guys to try the second one. I'm going to get out 9:48, 10:49, is that right? No. Yeah. We got an hour still?
Yeah.
I'm really in good shape. Courtney's like, oh my God.
This class is too
Not
exciting.
divided. Divided's like, I love this class.
This class is too exciting.
Like it's so much for your help. So I will give you a couple minutes in to try to do that one.
Yeah.
Did you do it? Let's see. Yeah, normally I think I walked around a little more than the last. It was a smaller class. I walked around a little more. Oh, but I am recording this too, though, so I guess it's not a big deal with one class. You're supposed to be doing the other one. If you didn't understand this, you're supposed to be doing the next step, not just copying what I have down.
Yeah, I know. Well, that's what Tyler got to do last night. That's what Tyler got to do.
I had already done that part. So I'll give you another minute.
Okay, buddy. The same thing that I did.
Was it? No, it wasn't. Not from the last problem, maybe a different problem.
The only difference is that the x was 1. Right?
And the y was what? 2?
Once you put up.
What?
Oh, shit.
Good guy.
Okay, well, that's a negative. So, yeah, that's such a thing. How you get a negative? Put a positive. Fucking cracked out. Oh. I know I ain't tripping.
That's right. So this goes away. You multiply 3 times 0, that goes away. There's no 3 there. Right? 3 times 0 is 0. So there's nothing over here. So what do you have left? There is nothing. That part of the equation is not left. Boy, I'm gonna walk around because first 2 or 3 people I looked at were not correct. That looks good. there. Did you finish it yet? Did you start it yet? No. All right. Again, this is about the point where I'm like, all right, fine. You guys are on your own. Like, you gotta try it. You get it wrong, you get it wrong. And then where we go?
Was that right done?
Yeah. Good.
Ryan, you said.
I'll come back and check final product.
You said you have a negative?
I didn't even do it. I don't know what I'm talking You went from +6
So
to
where
-6.
is the second
At all.
part?
See it?
Yeah. I'm stuck on it. I'm stuck on
It's
it.
the X
So this is, so
X.
all of this is what I.
-3y equals
So I'm not-
6.
like, You were supposed to
Then
plug
it
a
says
zero.
Minus
You plug a zero in for X here. And what next time you do it, you leave the X, and you plug a zero in for Y. So try to redo that, because I'm a little worried about some of you on this quiz.
Bro, why does it say +6 and then goes to
What is
-6?
negative 6?
I don't know.
What do you mean you don't know? You made the problem.
Oh, I just messed up.
See, I knew I was on to something. Where you on the -6?
I meant to make it a -6 so we had negatives again, and I just forgot to put it in the original. So yeah, you need to change that original problem, just put a -6 on the top. I mean, not the problem, but this same problem you're supposed to be finishing, but let's you make it a -6.
So what did that X be?
So that would change some of your answers that I said were correct, but that's fine. I mean, as long as you understand, you went through the right steps, that's all.
I mean, 0 will change. X.
Well, did we plug in?
Second time.
Well, that's, like, I did the
That's
first
part.
point, you gotta now figure out the second point. What do we do here? What do we do to figure out the second point? What's the difference between this? So here's the, so here, I want to do, actually, I knew where this was going. So this is like separate, that's 1, that's 2. So first time we did this, what's the difference in what we did the second time?
Took something away. And then you added the 2 back.
And then what we do instead of that. It's not really the 2 we're adding. It's really the variable.
Hey.
I may go over that sheet. Let me see if I can find that sheet. Well, this goes away. What's 3 times 0? Then that wouldn't be.
It's not-
3. You have the X,
Funny game.
but we don't, there's nothing, you divide by what's in front of the X. There's nothing in front of it. Oh, well, there's a 1. Technically, there's a 1. You're only dividing by, well, I'm gonna solve it out in a minute, but I got a lot, we're gonna do another one of these, because I got a lot of people that don't know what they're doing in the second step. Yeah. Answer.
6.
Well, technically -6, because I wrote the problem wrong, but the way you wrote it, yeah, it would be 6. So here, a lot of people are struggling with this next step. You're not understanding what we're doing. You're getting well, again, I did the first one for you, so we'll have to do another one in a second. So I'm going to do the second step of this. So that's the first part. That gave me the first ordered pair I put on the graph. Now I do the same exact thing. I start with the original equation, and I'm going to make it a negative. If you put a positive, then your numbers would be a little different, but so don't worry about my numbers, just worry about the steps I'm doing. Basically, where am I putting the 0? I replaced X before with 0. I said, what if X is 0, basically? What if X equaled 0? Well, if X equaled 0, I wouldn't need X anymore. I'd put a 0 there. Now I'm doing the same thing. I'm just saying, well, what if Y was 0? What if Y equaled 0? Well, I wouldn't put a 0 for X if Y is 0. I'd put a 0 in for the Y. So it's not that I'm like, I wasn't getting rid of any numbers. I was making the variable equal to 0. And then a number times 0 is just 0. So that's why the number went away. because I was multiplying it times the variable that I made equal to 0. So here, x doesn't go away this time. X is still just x. Y goes away because I'm making y equal to 0, because I said what if y equals 0. And then I just write the rest of the equation. So now 3 times 0 just is 0. So I have x subtract 0 equals -6. Well, x subtract 0 is just x. So I just have x equals -6. If you have a 1 in front of it, you could divide by 1 just to like do the same exact process. Say divide by 1 on both sides. -6 divided by 1 is still just -6.
I cannot make a straight line.
So now I just put a point on whatever you came up with. If you had a +6 because you wrote the problem as +6, because I think that's what I had initially, that's fine. You'd have a point on +6. I'm going to have a point on -6 because I changed it to -6 for me. And then I just connect them. And again, I don't care how straight your line is as long as you have those first 2 points in the right spot. So since we're in pretty good shape on time, I want you to try another one of those. Anybody still writing that? I'll go ahead and write the problem I want you to try over here. We'll say 2x subtract y equals -4. So try to do that one on one of the other blank graphs. 2x subtract y equals -4. I'm going to rewrite that. 2x subtract y is -4. 2x. I'm rewriting it. There. 2x subtract y is -4. Yeah, so you guys are doing this one on your own. Because I'm trying to figure out, is the mistake that you don't know how to do the second part, or is it that you don't know how to do it? Because I did the first part before you on the last one, so I can't tell if people knew how to do that. I didn't mean to. So you should have a bunch of examples worked out. There's one on the white sheet. Which
One sheet. No, there's like 4 different ones.
The white sheet that says steps to graphing in standard form. That one, correct. When I say white sheet, that's what I'm referring to as white sheet. If you want to like kind of write that on there saying this is what Mr. Gill calls a white sheet. That would be a tough color to not know. I don't think even colorblind probably would follow. White. You're colorblind? Are you really? So what do you have trouble with? Green and red? What? So you don't see anything? None at all?
What?
Really? I knew red and green for some people they saw as gray, but I thought they still saw other colors. You don't see any colors at all. That's crazy.
Yes.
So how do you know when I say red, blue, and whatever line?
I just memorized it.
Well, no, but like on one, were you here when I had I had a black line, a red line, a green line, and a
Well, they're
blue line? What's that?
a little bit different in shape.
But how do you know which ones? Like, do you know? Like, you say a gray, like for you, you'd see different shades of gray. Can you tell that shade of gray is red, that shade of gray is green, that shade of gray is blue?
Oh, no.
No.
So
That's
I,
crazy.
the only reason I can tell is if I can compare it to.
Once I tell you what it is, then from there you can see you'll know, okay, that's the blue line. Because I know he said originally that was the blue line. Yeah. They say it's more likely for a boy to be colorblind than a girl.
Little boy.
At least that's the way it used to be. I think like for every one girl that is colorblind, 4 boys are colorblind or something like that. I'll give you another couple of minutes. We got about 50 minutes, so I think we're still pretty good on time. Are you trying this?
Yeah.
Are you?
Yeah.
All right. You seem to be like messing around. What's your first step then? What's your first step yet? Is the step? The steps are on the white sheet. Like that's not only an example for you, it tells you what to do on the left side, like in words. So if you're not following the example, read the words. The words on the white sheet are on the left. It says step 1, how many steps are there? 5. It says step 1, 2, 3, 4, 5. And again, trying to follow those steps on quiz day is too late. You need to be working through them today. Well, really, you needed to be working through them when we were doing it the other days too. So read the first step, try to do what it's saying. If you don't practice using the sheets that I give you, then yeah, they're not gonna be helpful. But if you practice, I guarantee you they will work. I've done this and the sheets are better now than they used to be. So I know people that don't get it can use those sheets if they try to understand what the sheet is saying.
I don't know white sheet. I never got a white sheet.
Yeah, you were absent for a while. And I think I still had some of those left over because some of you people were absent that one day. Maybe. Does anybody else not have that sheet? It was here, or I'm sorry, it was absent. I'm just gonna give you one because you were. I'll have some of these in the room, but you're not hanging on to stuff. I'm not gonna continue to provide extra copies. Do you have this? I want you to at least read it today. I want you to give that back today, and I'll give it back to you. But try to follow those steps, the written steps. Like 1, 2, 3, 4, 5. You do miss some days, so I'm going to take for granted that you were here that one day. Well, you got to plug in for one of those variables. Yeah, but why? Yeah, but you're not showing me what the step is. Like, where did the 2x go? Yeah, but how did you get rid of it? How did you get just a? Well, you should.
I thought the math was not
So, okay, so if you're doing that, that's fine. Then what would you do next? So, and you would divide by 1, correct, or negative 1. That is correct. So it would become what? Well, positive 4. So let me see what you do for your next step before I. If you get the correct answer, then I'm going to be fine with what you're doing. Again, it's not really the way that I've shown you to do it, but if that works for you, I'm fine with that. As long as you can do it that way every time. So now, so you got 1 point now on the 4. So now show me where your other one. No. Where'd you get that? That one right. Wait. Oh, well, what variable did you have left in this? Because you kind of lost them both. How'd you lose them both? So one of them should still be there, one of them should be gone. So your number was right. The number part of it is correct, but you got to tell me which variable equals that number. And that determines whether or not you got it right. All right, so what happens to that?
Then you divide.
Well, first though, what's this math? Like, ignore everything under my thumb. What's the math that you see? Which is, well, what's the answer?
0.
0, right? So that goes to 0, which means all you're really going to have left is just the rest of the equation. So that would be the next step. Oh wait, where's your final answer? There's a step you didn't do though. You need to. So this is that divided by that, I believe. Well, no, you didn't write. That thing is glued to that. And that sign is glued to that. Glued to that. Which means that you made it. Change think. See what I'm saying? Everything, your stats look good though. Just keep that on that. So it wouldn't be just a 2. It would be 2 times 0. Plugging 0 in. No, you did it here. Here you plug 0 into y, and that went to 0. No, but you can't just move the x. The x doesn't go away. So be careful, because that's actually going to 2x. Here, you would be plugging in 0 into x. So this wouldn't be 2, it would be 0. And you would just have, no, you didn't get to the right thing. Negative y, negative 4. I think it was negative. And then well, you wouldn't divide by negative y, you divide by negative 1. You never divide by the variable, by the number. But that's not bad. You get, may not be a perfect 100% for that problem, but it's not bad. Probably a B, which will certainly be fine on a quiz, big quiz. Sure. There, well, remember, in the original problem. So if this was a negative 4, and it would have been a negative 2.
What?
No, I'm just saying in the original problem. You wrote the problem.
So what point is not the point?
Everything you did was fine. I'll be honest, I didn't even check. No, that was right. This side is fine. This side. Let's, you wrote the negative 4 there in the original problem. You didn't write it.
Oh.
So that's it.
So that always
So
changes
you
to a
did-
negative?
It didn't change.
Look.
No, it didn't.
Oh,
It's the original problem has negative at goofball. You literally wrote it in the.
okay,
on
so
the
that'd be
outside.
a negative 2.
That was fine. You just made that little mistake. I don't even know if I would have taken off. Like if you copy something down wrong, like when you go to solve a problem out, I sometimes don't even take off for that. Now technically it's wrong. So like on a multiple choice quiz, you'd miss it. But if you do all the steps right from the wrong problem, you started with the wrong problem. Worst case scenario, that's right. Got it wrong. What'd you do wrong? What'd you lose? Just magically disappeared. Where did something just magically disappear? You did all this right. But what happened? Something just disappeared. Just went away. What do you have in this middle line that you don't have down there? The 2x. Where'd that go? Down on the next line. Actually, that's all you bring down. You don't need to bring subtract 0 down. What is 2x subtract 0? 0. Oh, that's the problem. That's where you did it wrong. If you have 2 x's in your hand, if I don't take anything away from you, like I don't subtract anything.
Then that's not 2x.
So yeah, that was your problem. You just were thinking the wrong math. So yeah. Now I see. So that was actually not a big deal at all. So you see what I'm saying? So you'd write that down on the next line, then you need to solve for x.
Oh,
Got it?
yeah, I see it.
So yeah, just be careful on your math. Again, most math doesn't cost you much, but that was an example of where the math actually really changes things if you do the math wrong with a very long part. That's correct. What in the world did you do wrong, girl?
Oh, wait.
You divided by this on one side, but you didn't divide by something
right.
else on the other side.
Alright.
Word. Oh, what's that? Other one is 10. Didn't really show a bunch of work, so I'd show more work. Your answers look good. Just be careful about not showing work. Phone shouldn't be out. Hey, you didn't. Good and good. And then just put a point on those two and you're good. Let me see what you got.
negative values or
So it would have been negative y and negative 4, which means you got to divide by a negative on both sides. Because actually y is positive. Now that, is this the graph for that? Y is this axis. So y is negative 4, I'm sorry, positive 4 it should be. That goes on this. You did it reverse. Be careful. I don't. Show me how you got that, so I can't really check that one. I think the number's actually right, but. And then, like this would be a negative y. Remember what was in front of us, u2. So you have to divide by negative 1 by negative 1. We can change it to a positive. Your steps look good. I'll be worried about. Same thing for you. I think you forgot to divide. Negative. Oh, so this is the side. Oh, don't divide by what's over here. You divide by the negative what's in front of the y. Remember, you divide by what's in front of the variable, not by what's all by itself. You know what I'm saying? All right, and then you didn't plug anything in here. What are you doing there? Well, but what are you? That's not what we would do. What did you do over here? Your first step after you wrote the original equation. First thing you did. You plugged in. Well, you plugged in 0 for x. Right? Well, your first step here should be plugging in 0 for what? There you go. So the y basically is going to go away. You're just going to have 2x. I think you're good. You need to look at anything. You look like you were on the right track before. All right, so I think most people are in pretty good. Oh, let me add in. We'll call it. Oh, Willow, are you all right? No? Or yeah? Oh. Yeah, if you want to go, I'm about to solve it out. Are you good?
Yeah.
All right, so it looks like we're mostly good. I'll still solve it out real fast, just in case anybody wants to look at it. There's a lot of downtime on the recording right there, but that's all right. So first step, I need to make the variable x. What if x is 0? What if x is 0? Then what would y have to be to make the left side equal the right side? Well, let's see. If I plug in 0 for x, subtract y equals negative 4. 2 times 0 just goes to 0, so that goes away. I don't need that. So I have negative y equals negative 4. Now, a lot of you didn't bring that negative sign down with the y, so you got the wrong answer. Wouldn't have killed you on the problem. I'd still give you a lot of partial credit. But again, remember, on a multiple choice test, you would have gotten it wrong, because I guarantee you that would have been one of the options. So I need to divide by negative 1, because technically there's a 1 in front of that y. Well, if I divide by negative 1 there, I divide by negative 1 there, that gives me y equals positive 4. So I would go up to my graph, and I would put a point on positive 4. Again, on the y-axis. So now we do the second variable. So I write the original equation again. A lot of people are still a little confused right here. This time, again, I'm starting with the same original equation. Over here, I made x 0. Now I'm going to replace y with 0. I'm just saying, what if y was 0? Then what would x have to be? So I replaced that with 0. And I just solve out for the other variable. I'm always in the way, no matter which side I'm on. I'll get out of the way for you guys on the other side. So the 0 goes away because 2x subtract 0 is just 2x. So I'm left with 2x equals negative 4. I divide by 2, divide by 2. Then I get x equals negative 2. I'm sorry, positive. I'm dividing by positive 2. So -4 divided by +2 is a -2. So if I get x equals -2, that goes on the x-axis. So those are the 2 points you should have had. Yeah, I'm not concerned with how super straight your line is. All right, so that's all the graphing, boy. I feel like that took a long time, but I think we were pretty far ahead. Any questions on that? All right, so now let's go to the gold sheet. Gold sheet is the word problem sheet. I don't really have this on the, oh yeah, I do. I do have it up. There it is, right there. So here's a gold sheet. So that's the question we said was most important question. Because the first thing we have to do, kind of like graphing, we got to figure out which type of equation am I going to use. Am I going to use the y equals mx plus b when I take the word problem and I try to make it into an equation? Or am I going to say, well, I need to use a times x, so some number times x, plus, or it could be subtract, some number times y, and then equals some number. So I got to figure out which one of those to use. That's what this sheet is for, to help you figure it out, and it's also got some examples on it. Yeah. Oh, she's not here. Wait. Wrong. Here. Yeah. And she's in my 5th period. No, she's in 3rd period. That's not even saying. I gave you totally the wrong thing.
Thank you.
So again, this will help you figure out which type of equation you're going to use. Is it going to be the where you replace the m and the b, because you're always going to have the y and the x, or is it going to replace where you or be where you replace the a, the b, and the c, because you'll always have an x and a y in the equation when you create an equation. Pretty much. So if you read that problem, so look at the second question. It says, is there a starting number? Is there an initial number? If you say yes to that, if you're like, yeah, absolutely, I know there's a starting number. A beginning bank balance, like you start with $100 and you're going to add $10 every week. Or you start with a membership fee and then you're going to pay for every download for song or movie or whatever you download. You start with, what's another good initial? Although I don't really want to use these, but you start with, what's another really common start? Oh, remember we did the one where we were doing the growth, like how high a plant was. The plant started at 5 centimeters, and then on top of that, it grew some every day. So again, the 5 centimeters was a starting number. We weren't going to use the 5 again. That's where we start, and then we're going to add to that. You won't ever use the starting number again. You'll just use it at one time, and then you're done with it. You'll keep adding to it, but you won't use that number again. That's how you know it's an initial number. Let's say you read the problem and you're still not sure. I think this question is the next best question after that, second to last. Are you multiplying twice? So for example, we did a problem, if you were here, from this packet. And it was about selling t-shirts and shorts. We said, well, if the t-shirts are, I think the t-shirts were t-shirts were $6, shorts were $4.50 or something like that. No, t-shirts were $4.50, shorts were $6. We said, well, I know that somehow I'm going to have to multiply that cost of a t-shirt times how many t-shirts. So I got to multiply there. But I'm also going to have to multiply the cost of shorts times how many shorts. So I'm going to be multiplying twice. This is the only formula where you multiply twice. You're multiplying these two things, and you're multiplying these two things. Here, I would only have multiplication one time between these two, whatever the values are. So multiplying twice is another big hint. There's a bunch of other questions that can help you. I'm not going to go over every single one of them. You'll see, I think, when we do a couple of practice ones that it's pretty obvious, typically once you ask these two questions. The word per is also a good one if you know you're only using the word per once, but that can get confusing as you'll see in one of the examples. So look at this first example. I'm gonna zoom way in. So look at the example about Aaliyah. Here's what I want you to think about. Is there an initial, again, the first question, is there an initial number? Is there a number that we're going to start with, just use it that one time, but then we're going to keep adding to that number? So again, just on your own, nobody say it out loud. I want you to think about that. Then we're going to take a vote. And typically it's not a real low number that, well, that's not true. Sometimes it's a good number. Is there a number you start with and you only use it once? But you're going to then add something else to that number over and over again. You have this on your sheet, you don't have to look at the screen. And we're going to fill it in so you have a couple of examples on your sheet, at least. All right, so raise your hand if you think, yeah, there's an initial number to that. I don't know if Gregory is raising his hand or not. He started to. Raise your hand if you're like, no, there is not an initial number on that. I mean, a couple of brave souls. Huh? Raise your hand again. This is for you guys, not for me. Raise your hand if you have no idea what I'm talking about. Because only like 4 people raise their hand. So clearly a lot of you have, there's one that's brave. A lot of you have no idea. So again, let's think about this. I only got 3 numbers. I just got to see is one of those 3 numbers a starting number. So let's start with first number. Are we starting with $17 and then adding to that? What's it say that $17 is?
That's how much you spend.
Yes, that's where she ends. She finishes by spending 17. So that's not a starting number. So that's out. So are we, so airheads, here's the other number. You don't really see the number part, but that's a number, 1. Are we starting with 1? And then we're never going to use 1 again. We're just going to add to 1. Or is it possible that we're going to use 1 over and over and over again? Which one are you answering? So are we going to use 1 and 1 over and over and over again?
Yeah.
Why?
Because it's only $1.
What?
An airhead.
So is it possible we might get more than 1 airhead?
Yeah.
Then yeah, if we're going to get more than 1 airhead, we might use 1 over and over again. If we get 5 airheads, we got to use 1 5 times. If we get 10 airheads, we got to use it 10 times. If you're using that number more than once, if you're going to use it over and over again, possibly, it is not an initial number. Can't be. Because an initial number we use once, that's it. Then we'll add stuff to that, but we're not going to add that number to itself again. Only use it once, so that doesn't work. What about the 2?
Okay.
Is that an initial number?
Oh, no.
Could we maybe use it over and over again? Yeah, every time we buy a honey bun, we're using that number again. So that can't be an initial number either. That's all the numbers we got. There is no initial number in there. Let's say we still didn't know that. What's the next best question I said? Second to last question says what? Well, per is good, but I said, and per is this is actually the same thing as using per twice, really. Are we going to multiply twice? Are there 2 different things, maybe 2 different numbers that we're going to have to use to multiply times something? Yeah, every time I think of the cost of the how many airheads, I'm multiplying $1 times how many airheads. That's multiplication. What's the same thing for honey buns? I'm going to have to multiply that 2 times how many honey buns. So I'm multiplying with airheads and I'm multiplying with honey buns. That's multiplying twice. The only equation where you multiply twice is that one over there. AX plus BY equals C. So again, no initial value tells me AX plus BY. Multiplying twice tells me AX plus BY. I'm pretty confident it's that formula. It's standard form. So now, creating it, once you figure that out, creating it's not shouldn't be that difficult. There's only so many numbers. What is the formula? Does anybody did anybody do it on your paper? Try to do it on your paper then. I'm sorry, the equation. Like, what's the equation that would represent this then? If we know the format, we said the format's going to be the a times x, so some number times x plus some number times y equals some number. So the x and the y will be in this position where x and y are. Like when you create this formula, you could literally write, you could leave a blank and say x plus, although sometimes that will change to subtract, y equals, and then some number. So there's going to be a number here. So we got to figure out the number that goes there, figure out the number that goes there, figure out the number that goes there. And just coincidentally, we have 3 numbers in the problem. Let me let some other people do it and then we'll talk about it. I mean, again, once you know the format, the numbers should just kind of fall into place. Like it shouldn't be, so I would encourage you to try it right now in case you're not getting it. Maybe we can correct it. I'm not going to help you on the quiz to figure out where to go. Ever, she's missing this whole thing. Oh, well, so you can go back and watch the video. All right, so numbers should just kind of, what is the number that's all by itself at the end? Typically, in general, what's that number? Whether it's this formula or whether it's the other formula when y is all by itself. What do we say that number all by itself at one end is going to be? What? What's another way we describe it? It's not really the answer so much. There's another way we describe it. No, somebody said it, I think. It's the total, or I like better saying it's the final number. Because sometimes the total is actually a smaller number if you're subtracting from something and it's getting lower. So that doesn't always seem like total sometimes. It's the final number. It's wherever you end up. Well, he ends up at what number?
17.
Yeah, he spends 17. So he ends at 17. So 17 is going to go in that box. All right, that wasn't too bad. What about the number in front of the x? And it tells you in there what x stands for, right? What's x stand for, it says?
Airheads.
Number, how many airheads, right? So what number's got to go with that? 1, right? 1 is the only other number about airheads. I'm not going to put how much a honey bun costs in front of how many airheads. That would make no sense. So, like I said, kind of just falls into place once you understand which formula you're using or which equation you're using. So then what's got to go in front of the y? If y is about airheads, 2's got to go in front of the y. Now, if I don't tell you this part, if I don't say make x equal the number of airheads and y equal the number of honey buns, then it doesn't matter which number you put in front of x. You can put either one in front of x and then put the other one in front of y. But once you do that, you've just assigned to the variable what the variable is about. Because the number has to match up with what the variable is about. Like this is $1 per airhead, which means this has to be how many airheads. This is $2 per honey bun, which means this has to be how many honey buns. So those two things have to match up. All right, so now let's look at the one about Nikki to the right. Same question.
That's all we do.
Is
We don't
there?
solve for it.
That's it. Yeah, I'm not making you solve
On the
anything
test.
on the quiz. No solving at all. You just got to create the equation. Now, there are 1 or 2 equations in word problems where I give you the word problem and I give you the equation already. Like I say, this is the equation. And then I ask you questions about it. So those are going to be the harder ones in probably creating, I think. Because you got to truly understand what you're seeing as opposed to just put some numbers in front of a variable. So again, ask yourself the most important question, which is what?
What's the initial number?
Is there an initial number? And then if you say yes, there is, that tells you it's going to be that format, y equals mx plus b. The b would be the initial number, so that would go at the end. And then you just got to figure out what goes in front of the x, what number goes in front of the x. So try to do that one on your own, unless you have a pen. If you don't have a pen, you may want to do it on scratch paper or something. And then we'll put it on the sheet correctly. Because I want this sheet to be something you can use. Boy, we got slowed down too much. We got to speed up a little bit. This is recorded though, so I'll post it. So if we don't get to something, you can always go back and just watch the last piece of it. So I'm going to go ahead, and I'm not going to give you a ton of time. Frankly, I think this one's pretty easy to figure out whether or not there's an initial number. Is there an initial number in this one?
Yeah.
Maybe it's not. Do we have a number we're starting with and we're going to add to that?
Oh,
Yeah.
Yeah, 10, right? Now you might say, but wait a minute, we could say it's $10 per month. So we'd be adding that 10 every month, right? So I could see you saying that, and you'd be right. If we were adding it every month, that would not be an initial number because we'd be adding it over and over again. But here's the key to that. We're only looking at 1 month. We only want a formula or an equation that represents 1 month. So we're only going to use that 10 one time. If we're only using it one time, that is an initial number, an initial cost in this case. So our formula automatically is the y equals mx plus b. Well, y is an unknown. We don't know her monthly cost. And that's what y would stand for, by the way. Y is the monthly cost. Typically, y is going to be like, what is your final cost? If it's about money. It's going to be some final number, like some final ending number for y that we don't know. Now, I would start with, I'm going to do this a little bit out of order. I'm going to put the b value first, like the initial cost first, because I'm going to pay that before anything happens. As soon as I join the month, like it kicks to the first of the month, I owe that $10. So I pay that $10 for my monthly fee. So now if I download, and remember we said we could do this in words too. So we said total monthly cost in words equals I'm going to call it membership fee because that's pretty common. Even though here I just called it the monthly fee, I think. Yeah. So membership fee, I'll say monthly membership fee. How about that? So monthly membership fee plus the money spent on downloads. So in words, that's kind of what you could do, and I'd give you quite a few points for that. I mean, because that's the equation. You don't have variables and numbers in it yet, but that's pretty much the equation. The total monthly cost is made up of the monthly fee plus how much you spend on downloads. So now we're just converting that total monthly cost. We don't know, so that's why the membership fee was $10 plus how do I calculate out how much I spend on downloads? What am I doing there?
Divide it.
Well, let's think about it. It's 25 cents per song. You download 10 songs. What do you do? What math would you do to figure out how much it cost you to download 10 songs?
25 cents can go on.
Do what? What math did you say?
Yeah, division.
No, you didn't. You said times.
Oh, yeah.
You literally said times, dude. And you said that's division.
Yeah, but
So it is 25 cents. That's pretty easy to know. So you know the 25's got to be in there because that's how much a download is. But then you're multiplying times how many. I said this the other day. This is going to be a common theme and throughout any creating equation. How many? Oh no, not how many. I mean, it will be how many, but I don't want to do that part first. How much is or how many in one? Because sometimes we'll say like how many people in a car or how many people in a bus or something like that. So you got to say how many in that case. And then times how many of them. That is extremely common for the two things you're multiplying. Pretty much every single time, actually. I don't know if you're ever going to see an exception to that. One download is 25 cents times how many downloads. How do we represent how many downloads? What do we put for that? How much is one download is easy. That's 25 cents. How do we represent how many downloads? Not Do we know it? So what do we do when we don't know something? What do we use? What's an unknown? What do we say an unknown is? What do we use for an unknown? Well, not the math. The math is multiplication. You're right about that. So we are going to multiply, but what are we multiplying it by? If it's an unknown, we don't have anything to put there. So what do we put there? Yeah, variable. So we already use y. So and y is typically the total. So times x. So it's y equals 10 plus, and we wouldn't need the times, but 0.25x would be the equation. So y equals 10 plus 0.25x would be the equation for that second problem. All right, so let's move on. I slowed down too much, I think. 149. We might be all right. We need to do some equations because there is a section on equations. Restroom.
Yes.
I'll go and do this first. Who has their hand up first? Thank you. All right, so equations really quickly. I'll do a couple of them. Oop. Oh no, I got to go back to the other. Oh, there's my word problem right there. We have a new. Oh, is it not over there? Oh, Damani's out. Go ahead and go out without it and find her. About time. Where have you been? Walking around school, looking for friends, hanging out is where you've been. You're gonna have to watch this video because you missed an entire section of the quiz.
Okay.
So make sure you go back and watch the section on creating equations from word problems. All right. So here's the review. We've already done that. So now we're going to do some equations. That was the creating. All right, here we go. I'm just going to get rid of that whole thing. All right, so there's one. Now there's two-step equations on it. So I'm not going to go over two-step equations. You should know how to do those. Plus, we're going to do two-step equations in the longer equation, so you'll still see it. So there's one, something like this. Actually, I'm going to use really big numbers so that I don't duplicate anything. There. So there's an equation. If you don't know what step you're on the pink, so this pink sheet.
Oh, shit.
So the pink sheet is the equation, solving equations. We hadn't used it in a while, but it still works. If I don't know immediately that I'm on step 4, which is where I'm at on this, just start at the first step and work your way down. Do I have parentheses? No. Then I'm not on step 1. Do I have like terms on the left side? So again, that separates left and right. Yeah, these are not like terms. I can't combine something with an X and something without it. Do I have like terms on the right side? No. So I'm on step 4. Work your way down to where you're like, okay, yeah, now I have what I'm looking for. So it says on step 4, we did an example like this before the last exit ticket. It says get rid of, and then it says, oh no, it doesn't say this. I said you can change get rid of or not change it, but maybe make a little note. Get rid of just means start with. So it says get rid of, which just means start with the variable term on the right side of the equation. So it tells you where you're starting. I'm starting with the term 19x. That's the only one on the right that has variable in it. So I'm starting right there. It then says you're going to add or subtract, and it says do the opposite. Is that 19x, positive or negative? Yes, whatever's in front of it determines the sign. Well, I didn't have a negative. In the other class, I had a negative there. Should have done that. Whatever is in front of it is the sign, though. Remember that. So if that's positive, it says add or subtract. The opposite, you better know, is subtraction. So now it doesn't say this, but if you know the number 1 rule, you know you got to come over here and do that. Don't put it under the 11, negative 11. It doesn't have a, or it has a variable in it, so you got to put it underneath the term with a variable. Well, that gives me negative 7x. Subtract 11. That goes away, so I just have positive 31 on that side. Are you kidding me? That's too funny. This is twice that I just randomly pick numbers and it's going to come out to be an even integer. The odds of that are like practically 0. So now you just have a 2-step equation. You should all know how to do that. We start with we start with the number that is the constant. So we're starting with the negative 11 or subtract 11.
Yeah, that's just going that one.
Just not even true. So I say, all right, well, I got to start here. I do the opposite. And again, the steps for solving two-step equations are at the top of your pink sheet. If you don't remember that, I hope you got this stuff down.
Yeah.
You get some good quality poems out of it.
Start with the constant and it's on the same side of the variable.
Yeah, at the top, it tells you these steps if you don't remember. So that's going to give me 42. I just bring down, that goes away, which is what I wanted. I wanted to get rid of it. What does solving for a variable mean? Yeah, we're just trying to get it by itself, which means we got to get rid of the 11 and get rid of the negative 7. You have the answer? What do I do next then?
Divide -7.
Yeah, if this is negative 7 times x, I need to do the opposite of multiplication, which is division. 7 divided by negative 7. So, and again, can't believe it happened to come out even. X is negative 6. I'm pretty sure you get fractions on the quiz. So when you get a fraction, don't be surprised.
Are you the one that made the quiz?
Oh yeah. I just don't remember.
Saying pretty sure.
I don't remember what I did. I made it like over the weekend. I don't remember exactly. I know I normally make these at this point of the year. I normally make them come out to be fractions because you should know how to do the steps, and sometimes there's a way to figure it out without doing the steps if I don't make them fractions. You could just keep guessing at numbers until you got the right number. Any questions? I'm gonna do one more real quick. It's not gonna be the same kind. It's gonna be, there's another one type that's on the quiz. All right, anybody still writing that? You can go back and watch the video because I gotta get going. I took a little too much time walking around checking earlier. So there's another one on, it's something like this. I don't remember exactly what it is. 3x, subtract, oh, actually, no, it's not like this. I don't remember what it's like, to be honest. So I'll do high numbers again. Use y. Oh boy, I really don't remember how I did this. I'm trying to give you one that's pretty similar, but I can't remember. I don't know. I ran out of room. So I'll read that if you can't see it. So it's 13y subtract 14. So 13y subtract 14 equals -2, and then parentheses, 9y subtract 12, close the parentheses, and then plus 6. I think you can all see that, but just in case. So now, what do I need to do first if I'm starting at my sheet? Well, what's the first step? What do I have to check? Well, but what is that called? Do you remember? Yes, I got to do distributive property. I need to do what's in parentheses times that -2. Now, I told you to do this. Use the negative sign for the 2 times 9y. Negative sign on the 2 times -12. So I told you to kind of write that out up there above the problem. So now I can write the new next line. What is -2 times 9y? -18y. Don't forget the variable because that'll change the whole problem. So now what is negative? So now I'm going to this part over here. What is -2 times -12? Plus, which a positive 24 I write as plus 24 now that I'm creating the equation. So plus 24, and then I just have the plus 6. So now we did the distributive property. We're done with step 1. Step 2 says, do I have like terms on the left? No, those are not like terms. I can't combine something with a variable and something without a variable. All right, do I have like terms on the right?
Yes.
I do. It's either got to have the same letter, which we don't have. There's nothing else with a y. But it can also have no letter at all. Well, those don't have letters. Those are constants, they're just numbers. So I can just, again, I don't do anything underneath the equation. That's the mistake that people are going to make. What's the mistake that I'm looking? Oh, graphing. I got to remember that. People going the wrong way with the rise and the run. If nobody does that, then there's a reward for the class. I should do that reward on this too. If nobody makes the mistake of doing something underneath the equation here, maybe I'll do something also. Yeah, why are you? We got like 7-8 minutes. We got a whole nother topic we got to do. So, plus 30. Yeah, there's another topic on there that we haven't reviewed yet. I'm not reviewing the stuff we did yesterday, but there's another one that we haven't reviewed. So, I have 13y, subtract 14. So now, I am at step 4. That's what we just did. We just did the problem before, was at this step. So I'm going to do this pretty fast. I start with the term with a variable on the right. I add or subtract, and it needs to be the opposite. Well, that's negative 18y, so I need to add 18y. Well, if I add 18y there, I got to add it over here. 31y subtract 14 equals 30. Well, now I'm at a two-step equation. You should know how to do a two-step equation. Start by adding the 14 to both sides. I still have 31y on that side. So I divide both sides by 31. Now I got a fraction. Good. That's all you do if you get a fraction. A lot of you are trying to do more after that. That's it. You're done. I mean, if you can simplify it, I guess simplify it, but normally the fractions I give you can't be simplified. So your answer is just y equals 44 over 31. 44 divided by 31. You don't have to change that into decimal. You don't have to change it into a mixed fraction. That's it. Any questions on anything I did on that before we go to the last topic? So the last topic is the graph that I gave you that already had lines on it.
Yeah, we literally got 1 minute.
He don't.
What are you talking about? Oh, we do have 1 minute. I'm sorry. I was reading the... I was thinking we had 5 minutes. All right, so we didn't do this one. You can watch the video for that. How to create an equation from a line that is already on a graph. Oh wait, no, I'm going to have to do that one on my own then, because this is the class I'm recording right here. I'm going to do that real quick. So you guys can be quiet, please, because I'm going to add that to the video so everybody can see it. All right, so if we have a line, on a graph, like right about there. All right, so this is a line on a graph. It's not going to be a perfect line because I didn't put it in the right spot, I don't think. Here are the steps to creating the equation when you have a line on a graph. So, first step, it's very similar to using the yellow sheet to create a line from an equation. We're going to use kind of some of the same stuff. The first step, we got to find the y. Oh, you can go ahead and write it this way because we're only going to create equations that are in the y equals mx plus b format. This is the only type of equation you have to create. So, first step, you can actually just go ahead and write this because you know that's the only kind of format you're going to use, so you can just write that down. I'm going to need to figure out what is the m value, so that's what's missing there. What is the b value? It's two things we're missing. Y and x are always going to be in there, so you can start with that kind of that template. So the y-intercept, which is the b value is the y-intercept. That's just wherever the line crosses the y-axis, so right there at -3. So I can just write -3 at the end. That's just the y-intercept. For the m, the slope, I've got to use the rise and the run again, just like we did in the other kind of problem. I'm doing this pretty fast. The key is I got to pick a spot where I'm going through corners. So that's the corners of squares. So that's a good spot to use. This one right here is not exactly through the corner, so it's not a great one to use. This one actually is pretty good, even though I think I come up with the wrong numbers if I use them because my line's not in the right spot really. So corners of squares is what I use. from there, I just say, well, I need to go right first because I start with the left point. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Down. If I go down, it is a -8. That's a +5 because I went right. So +5 was my run. -8 was my rise because I went down. So that's what I plug into the equation, and that's your equation right there. Now, if you use the other point, you would have actually gotten a different slope, but that's because I think these squares are not exactly square. I think they're off a little bit. So again, that's a super quick version, but there's another video where we did that one day. I don't remember which day it was, but it was probably, oh, I think somebody said it was last Thursday, I think. So last Thursday, I believe, is when I recorded 6th period. And that would have been, I'm sorry, October, what was it, 28th, I believe. So if you want to watch the more detailed video of that, to review.